tayo ditong bagong IC. Oh, SN74LS07N IC. Siya ay 14 pins. Ha? Binili ko pa ito sa Quiapo. Ha, matagal na. Ngayon ko lang gagamitin.
Ano yan?
Uy, sino yun?
Para saan yun?
Oh, Patrick, ikaw ba yan? Patrick? Patricio?
Hindi ako si Patrick. Kapatid ko yun.
Oh, parang ikaw yung nagtitinda ng DVD sa Quiapo ah. Oh, batang Quiapo ka.
Ano yan?
Ito? Di bale, ito ay buffer gate.
Para saan yun?
Ginagamit ito sa pagdidesign ng circuit, mga switching circuit. Oh, diba? Mabuti pa ilagay natin sa circuit para maintindihan natin. Okay? Ito na ang bago nating project circuit. Oh.
Ha? Ano nang nangyari dyan?
Ay, ito, naka-breadboard siya. Yung mga yan, jumper wires yan. Yun yung ating IC. May push button. May mga resistor. Ito yung power LED, input LED, at output LED.
Ay, ano namang mangyayari niyan? Anong gagawin mo na?
Ba? Ikakabit natin siya sa ating mahiwagang adjustable power supply. O yan, nakakabit na siya. O.
Wala namang nangyari dyan.
Ayun may na, supply. 5 volts, 5.03 volts. Current consumption, 7 milliampere. Power consumption, 35 milliwatt. May power na siya.
Uy, ano na ngayon yun?
Ito ngayon ang buffer gate. Nakikita mo dyan, umiilaw na yung power LED. Diba? At pag pinindot ko yung switch, umiilaw yung input LED. At pag pinindot ko, ayun diba? Meron siyang output. So, pag may input, merong output. Pag pinindot mo, ibig sabihin, yung kulay dilaw na LED, meron siyang input na pinindot mo yung switch. At may output every time na pinipindot mo yung switch. Ayan ang buffer gate.
Wala namang kwenta yun. Simpleng-simple naman yun.
Ha? Yan ang buffer gate. When there is an input, there is an output. Diba? Oh. Yan oh. Oh. Ano na ngayon ang kanyang current? 14 milliampere at 5 volts. Pag wala, 6 milliampere. Tumataas yung kuryente. Siyempre, tumataas din ang power consumption, 75 milliwatt. Oh. Diba? Yan ang kagandahan ng adjustable. Meron siyang voltmeter, ammeter, at wattmeter. This is now the circuit diagram of power IC. Okay? We have this in figure 1 IC circuit diagram. We're using 5 volts. And we have this power LED connected to the 5 volts. So when there's a power, it indicates that there is a power when this LED red turns on. So this is a power LED because the current flows directly into the LED. And then outside the IC, we have this switch connected to pin 1. Also connected is the input LED. So there is a current limiter just like here to limit the current flows into the LED in order not to burn the LED. Yellow input LED connected to the switch and the input pin of the IC. And then we also have this resistor 330 ohms connected to pin 2, which is the output, and also connected is the output LED to the ground. So for this IC, we have this internal circuitry of this 7407. So inside the IC, we have 6 buffer gate. Input 1, 2, out, 3 input, 4 out, 5 input, 6 out, 7 ground. Pin number 8 is output. Pin number 9 input of another buffer. Pin number 10 output, input, output, input, and then power of the IC plus BCC is connected to pin number 14. We're only using one buffer. So this IC is called hex buffer because it has 6 buffers. 6 buffer inside the IC. We're only using one buffer. So that's why we're only using pin number 1, which is the input of the buffer, and pin number 2, the output, and then the supply 5 volts to the pin number 14, and pin number 7 is ground. Ground, BCC, pin number 1, 2, and 1. Okay, and since we're only using one buffer, this is the buffer symbol. A triangle with an input A and output Y. So A is input. If there's no input, Y output. There's no input, there's no output. 0, 0. 0 means no input or low level. There's an output 1. If there's an input 1, there is an output 1. So this is a buffer. This is a truth table for this buffer gate. And the equivalent circuit for this IC, a simplified schematic diagram, is this. Since we're only using one buffer, so it is connected to the switch via 5 volts and then to the input with an input LED. This is the power LED. The same external resistor to the output, and then the LED to the ground. So the output is connected between the resistor 2 and the LED. Okay, let us now see the initial state of the circuit. Why is it that when we did not press the switch, LED did not turn on? So when we are not pressing the switch, LED turns off. Why? Because this buffer is grounded by a 330 ohms and a yellow LED. This serves as an input LED. That's why when we are not pressing the switch, it is grounded. Zero or low level, zero. Almost grounded. So why is it that LED did not turn on? Because the current flows into the R2 and then inside the buffer. It will not flow into the LED. So this LED turns off. This is off. Because the current flows into the 330 ohms and into the inside the buffer. Why is it that why is it happening, or what happened to the circuit? Why is it flowing inside the buffer instead of the LED? So if we're going to examine the internal circuit diagram of the buffer gate, it consists of, so inside the buffer, inside this triangle, we have 4 transistor NPN and 1 PNP. Of course, we have this resistor, current steering diode, clamp diode, or a Schutzki diode for reverse polarity, and then this one for stabilizing. And also we have the resistor, and then we have the out, just like here, out, BCC. So this buffer is an open collector type. Open collector, there is no components connected between the BCC and the output. But in our design circuit, we are connecting an external resistor, 330 ohms. So initially, this type of circuit or this IC, it is open collector output. The collector is open. There is no resistor between BCC and the out. So this is the output. In our project, we are connecting a 330 ohms. So we have connected this resistor between BCC and the out. So, and also, we connected to the out, between the ground and the out, an LED. Okay? So this is external resistor and external LED. This all transistor, this one is PNP type. Okay, PNP and 4 NPN are all inside the triangle or this buffer. So if we're going to ground, just in this case, since the switch is open, so this is grounded by this input LED. There is no current that flows from 5 volts. Grounded, so it is grounded. So inside the circuit, what happened is BCC, which is connected to the buffer, the current flows into the 9K, to the PNP. So it forward bias this transistor, and then to the ground. Because initial state, this is grounded. 0 volts or low level, 0. Grounded, it flows to the ground. And then, because of that, it will flow directly to the ground. This transistor will saturate. So the current now flow from emitter to the base and then to the ground. Because this is grounded, as we have seen here. So the current flows to the ground. And then, it will saturate this transistor, PNP type, it will flow to the ground. So if the current flows into the ground, what happened to the current flow into the diode? It will not flow to this direction, to this diode, since it flows directly to the ground. So what happens is, if there's no current here from the base of this NPN transistor, there is no current to the collector, to the emitter. It is open. There is no base triggering current to the base of this transistor because the current flows directly to the ground. It becomes open. If this is open, what happened to this transistor? It will also make this transistor to open because there's no current that flows into the base. Because this is open, this is also open. No current that flows into the collector to the emitter. So open, open. If this is open, open. Now, the current flows into the 5K from BCC 5K, switching this transistor on. So if the transistor is turned on, if you switch this transistor due to the current that flows into the 5K to the base emitter, it will switch on the transistor. The current will also flow into the 1K. It will now flow into the collector to emitter, making this transistor to close as a switch. So there's a current that flows into the 1K and to the power steering. What I mean is a diode steering diode. Diode steering diode. Okay? And then, since this is open, it will flow into the base of this transistor, switching this transistor on. So these two transistors are on via this current sense resistor. It is some sort of emitter follower configuration. So this is on. What happens now if this is on? So the collector of this transistor, since we connected an external resistor, just like this, will flow inside. So it will flow inside this transistor, the output of this buffer. So the current flows into the R2 and to the inside of the buffer. So the current flows from R2, this one is R2, and into the out or inside the transistor. So there's a transistor inside the buffer. And then to the ground. What happened to the LED? It will not turn on because the current flows directly to the ground, short-circuiting this transistor. The current will not flow into the LED, just like in this case. It will not flow to the LED. It will flow directly to the buffer. Okay? That's why LED is turned off by not pressing the switch because the buffer is grounded. And we connected a resistor, external resistor, and the current flows directly to the ground. Okay. That is the first condition. If we're going to press the switch, since this is open, so it becomes shorted. Press the switch. Current flows into the input LED. Okay? If the current flows to the input LED, it will turn on because there's enough current to turn on this LED. So, when we press the switch, as we have seen in our testing, yellow LED turns on. And the output also turns on. So, input LED turns on, output LED turns on. So, when we connect this input to the 5 volts, since we have the 5 volts here, the current will flow into the base of the PNP. But since this is a PNP type, it will reverse bias this transistor. The transistor will not conduct. If this is NPN, it will conduct just like this one. If this is PNP, it will not conduct reverse bias because the current flows into the emitter to the base. That is the regular flow of current of the PNP. But this is PNP, so connecting the 5 volts as we have seen here, the switch, the current, it injects a current to the input just like this one. But since this is PNP, it will not affect the circuit. It's reverse bias. If this is reverse bias, what happens is BCC now flows into the 9K and then to this steering diode. That's the steering diode. What's the use of steering diode? To make sure that the current flows into the base of this second transistor. So the current flows into BCC 9K resistor to the steering diode to the base, switching this transistor on. Now this is on. Okay? Also, the current flows into the Schottky, back to the base of the PNP, and it will not, there's nothing will happen. What's the use of this Schottky? Well, for stabilization, because transistor is a parasitic components. It composed of lots of capacitance or any parasitic elements. It produces a capacitance, inductance in the during operation. So we need this. They connected this Schottky, some sort of a Schottky diode. Low voltage, low drop up voltage diode. So the current flows into the power steering diode, then switching this transistor on, NPN type. If this is on, there is a triggering current to the base of this transistor. Now the current flows into the 5K and then to the collector to the emitter. Since this is switch on, so the collector to emitter, the current will now flow into the collector to the emitter, switching or saturating this transistor. This is now on. If this is on, there is a current that flows into the 2K, to the ground. There is another current sense resistor. All the current will flow into the emitter current of this transistor. That's why it's called the current sensing resistor. So there's a current here. It will supply a current to the base. Since this is on, there's a current flow here. Current flows also to the base, making this transistor to turn on. So if this is on, what happened now to this transistor? This will now become open, since the current flows to the second transistor and then to this transistor. So this will make this transistor, since this is the current flows directly to the ground, we don't have any current to flow from collector to emitter because this is open due to the current that flows to the collector to emitter of this transistor by passing this transistor. So this is open. This is open. There's no current also that flows into this transistor. Open. So what happened to the circuit? Now the current will now flow into the resistor. So instead of flowing inside the buffer, it will not flow to the LED. So it will flow into the LED to the ground, making this transistor to turn on. So this is now on. But because this transistor is off, This is off. This is off. So there's no way the current flows into the collector to emitter to the ground of this transistor, because this is off or open. This is off. This is off, because all the current flows into this, we call this transistor phase shifter. It is between the common emitter and the emitter follower type configuration of transistor. And this two transistor, it is usually used in the buffer gate design. What's the use of this steering diode? In order not to prevent the leaking the current back to the transistor. And what's the use of this Schottky diode? To avoid the reverse polarity connection of the battery. If you connect the wrong polarity, or if you connect the positive to the ground and then the negative to this input, it will just protect the circuit, the whole circuit, from burning, or it will not destroy the circuit because it protects it. The current will just flow into the Schottky back to the ground. So this is a reverse polarity protection, the Schottky. So that's why LED turns on when we apply a switch, when we press a switch. Okay? So, why is it letter A and letter Y? It is usually used in the school. A represents switch 1. So, A is equal to switch 1. So, when switch 1 is 0, it means you did not press the switch. It is grounded. When switch is 1, you press the switch. So when you did not press the switch, there is no output. When you press the switch 1, there is an input, and then also there is an output. So that's why that is the legend of this, the origin of these two letters. Usually used in the school, or at the school, in the school. A represents switch and Y is the output. Out. A, Y. So that's why we connected an external resistor, because it is open collector. And the LED is connected between out and the ground because of this internal circuitry. So this type of IC is composed of transistor. This is called transistor logic. Okay? I think this is a TTL type.